Hi, my dear students. In this session, we are going to continue our previous topic called acceleration due to gravity. And you can see here the quick recap of acceleration due to gravity. We are going to do that. Then the new topics will be discussed in this session itself. Right? I hope it's very clear for you now. So acceleration due to gravity is denoted with the symbol small g, whereas capital G is, we had already discussed, the capital G is what? So which is a universal gravitational constant, which is capital G. And in the last class, our major discussion was that the relation between small g and capital G. What was the relation between small g and capital G? Small g and capital G are related in this way. Small g is equal to capital G, capital M by R square. I hope you could recollect it. So what is this g here? Acceleration due to gravity on the Earth's surface. So what is this capital G here? Universal gravitational constant, and whose value is 6.67 into 10 raised to minus 11 Newton meter square per kg square. And this m is mass of the planet. Okay, so I'm just writing the same here. So G suffix E is acceleration due to gravity on the planet. That may be the Earth, that may be the Saturn, that may be the Jupiter, anything. So acceleration due to gravity on the surface of the Earth. Here we had taken the planet called Earth here. And what is this m? So this is the interesting part. M is a mass of the planet. See the interesting thing. So mass of the planet. So here also we had considered that is mass of the Earth. Okay. So R is the radius of the planet, and here our radius of the planet is the radius of the Earth. Understand? So radius of the planet, here we consider the Earth. Right? So I'm writing here, as it is acceleration due to gravity on the surface of the small g is equal to capital G into mass of the Earth divided by radius of the Earth whole square. So if it is some another planet, so let me draw the same expression. So acceleration due to gravity on some other planet, which is equal to capital G into mass of the other planet divided by radius of the other planet whole square. Here an important thing you should understand related to the radius of the planet. Right? So actually it's not the radius of the planet, it is the distance between the two masses. Distance between what? Two masses. And let's understand that. So let us recap your previous diagram. So what was our previous diagram here? You can see there is a planet here. On the surface of this planet, so there is a small mass is kept, and this is what? A huge mass, which is mass of the planet, and the mass of the planet will be having the center here, so which is C. Okay, so there are two masses here. So what are their centers? So this is the mass of the planet center, and this is the mass of the body center. So they are at a distance which is equal to radius of the planet. Right? In reality, your R is the distance between the two bodies. So in this case, the distance between the two bodies is equal to radius of the planet. Right? I hope it's very clear to you. So on this case, what we had discussed, acceleration due to gravity on the Earth's surface is equal to capital G value, you know. Mass of the Earth case also we had discussed. And radius of the Earth case also we discussed. And what is the radius of the Earth for your better understanding? So let me write here somewhere. So the radius of the Earth here, only I am writing here. So radius of the Earth is equal to 6,400 kilometers. Okay. No need to remember. I am just giving you the value. So radius of the Earth value and mass of the Earth value and G value, if you substitute acceleration due to gravity on the surface of the Earth, you get it as 9.8 meter per second square. Okay. Whereas acceleration due to gravity on the moon surface, if you find out, so you get it as 1.63 meter per second square. Okay. Clear? So from here, if I write acceleration due to gravity on the moon surface by acceleration due to gravity on the earth surface is equal to 1.63 meter per second square divided by 9.8 meter per second square. Meter per second square cancel here. So I can write 1.63 once and 1.636 are 9.8. You can also check. Right? So what is the ratio we have got? 1 by 6. From here, I can write acceleration due to gravity on the moon surface is equal to 1 by 6 times of acceleration due to gravity on the earth surface. You tell me where the acceleration due to gravity is more, on the earth surface or on the moon surface? So definitely on the earth surface it is more, and especially on the surface of the planet, acceleration due to gravity is its maximum value, right? So when you are moving away from the surface, the acceleration due to gravity decreases. When you are moving below the surface of the earth towards the center, acceleration due to gravity will decreases. Okay? Clear? Acceleration due to gravity will always having a maximum value on the surface. So the same things I'm just going to write here. So G value on any planet you can say. So the G value will be always a maximum on the surface. Maximum on the surface. Alright? So if we are moving away from the surface, small g value will decrease. In the same way, if we are moving towards the center, so from the surface, if you are moving towards the center, so your G value will decrease. Listen to me, very, very important statement I have given here. So G value will be always maximum on the surface of the planet. That may be the Earth or Moon or any other planet you consider, right? So of course Moon is not a planet. I am talking about anything, right? On any surface. So G value will be maximum. And when we are moving away from the planet surface, the G value will decrease. When we are moving towards the center from the surface, the G value will decrease. Okay, clear? And the most important part, so today's class itself, we will be discussing about the proof of these two expressions, right? So not only two and the three expressions. So today's class only the proofs we will be discussing. The very important and interesting session is today's. Right? Ready? Now, so let us take this example here. So this is what the expression, what I am writing. Acceleration due to gravity on the moon surface is equal to 1 by 6 times of acceleration due to gravity on the earth surface. So from this expression, both the sides, if I multiply with mass of the object, what happened? Look at here. M into acceleration due to gravity on the moon surface, which is equal to 1 by 6 times of m into acceleration due to gravity on the earth surface. And the most important part you get here, you can see. So we had discussed at the starting point of the chapter called gravitation, the difference between mass and weight. So what was the weight actually here? So weight of an object is equal to mass into acceleration due to gravity. And at each and every moment of the session, you should understand the difference between small m and capital M. What is the difference? Small m and capital M. Where small m is mass of an object which is placed on the surface in our example. Small m is mass of the object, whereas capital M is mass of the planet. I hope you got the point. Capital M is mass of the planet and small m is mass of the object which is kept on the surface. That's it. Right? Now come back here. So what is small m into the g of the moon. So can I say that it is weight of the object on the moon surface? Weight is equal to m into g, right? So I can write this as weight of the object on the moon surface, which is equal to 1 by 6 times of. So can I say this is weight of the object on the earth surface? So definitely it is s. So weight of the object on the earth surface. That's it. So this is the relation you get between weight of the object on earth surface and on the moon surface. So the questions will be asked like the basic level questions I am telling you. Questions will be asked in this way. Given weight of the object on the earth surface is 600 newtons. So what is the weight of the object on the moon surface? Tell me. It is 1 by 6 times of weight of the object on the earth, which is 600 newtons. So I can say this is 100. So weight of the object on the moon is 100 newtons. Look at here where the weight of the object is more. Weight of the object on the earth is 600 newtons. On the moon is 100 newtons. So it is more. Okay. So the same question, so for your better understanding, so let's see, weight of the object on the earth is given as 360 newtons. I hope you can calculate the weight of the object on the moon. So weight of the object on the moon is equal to 1 by 6 times of 360 newtons. How much here? So 660 is clear. So weight of the object on the moon surface is equal to 60 newton. That's it. Okay. Clear? Now. GE is, this is what the quick recap. What we have discussed already within this 10 or 15 minutes, we have just quickly revised the complete concept of last session, right? So now this session we will be discussing now. So get ready for that. Let's see here. We know acceleration due to gravity on earth surface is equal to g into mass of the earth by radius of the earth whole square. Right? So what you should understand, three important points here. Three important points. Number one. So this is the acceleration due to gravity on any planet is depending on mass of the planet. Okay, so I'm writing here, so acceleration due to gravity is depending on a mass of the planet, the first important thing. And the second thing is, the same acceleration due to gravity is depending on radius of, I'm talking about on the surface, it's depending on radius of the earth. So the same thing I'm writing here, so radius of the planet. Radius of the planet. So these are the two important things, and acceleration due to gravity is depending on these two important things. And anyhow, the acceleration due to gravity is depending on capital G also, whereas capital G is constant on any planet. So not only on the surface of the earth, so on any planet or anywhere in the universe, the capital G value remains same. So that's the reason I have written only two, mass of the planet and radius of the planet. Now, this is the acceleration due to gravity is independent of, this is the most important part of this session, independent of mass of the body. Independent of what? Mass of the body. That means small m. Remember this. Okay. So acceleration due to gravity is independent of mass of the body. That is only depending on mass of the planet. Okay. So now look at the interesting part here. So there is a planet. There is a planet. Acceleration due to gravity on that planet is Gp. In this planet, mass of this planet is 2 times more than the mass of the Earth. And radius of this planet is half of the radius of the Earth. Now in this case, what is the acceleration due to gravity on this planet? That's the question, right? It is so simple. So acceleration due to gravity on any planet is equal to g into mass of that planet divided by radius of that planet whole square. You just substitute all the values whatever it is given. So capital G into, what is mass of the planet? The mass of the planet is 2 times the mass of the Earth. So 2 times the mass of the Earth divided by Radius of the planet is half of the radius of the earth. So radius of the earth divided by 2 whole square. Remember. So this is the radius of the planet whole square. Okay. So from here, so you can write, so acceleration due to gravity on that planet will be equal to 2 times capital G into mass of the earth divided by radius of the earth square divided by 4, right? This divided by 4 goes to the numerator, so that will be written here. So what is your answer here? 4 into 2, so that's 8 G capital M suffix E divided by radius of the earth whole square. So what I can write, acceleration due to gravity on this planet will be 8 times acceleration due to gravity on the earth's surface. So what is this expression? So is this expression acceleration due to gravity on the surface of the earth? Yes, exactly. So on this planet, acceleration due to gravity is 8 times more than the acceleration due to gravity on the surface of the earth. I hope it's very clear to you. Now, the most important topic for the NEET exam we are going to discuss. So, 2 cases are very important for NEET exam we are discussing, and very important as a conceptual questions, where 99% of the students will do mistake, commonly doing mistake here. So what are the 2 cases I am writing here? So 2 important cases for a NEET exam, conceptual cases, are the CET exam, are in your JEE exam also. 2 important cases. So let's say this is what the first important case we will be discussing here, and this is the second important case. So that both will be at the same point, the same place. Right? So it's a ground here. So this is the ground. Carefully see here. So there is a body of mass 1 kilogram is dropped from here, from the same height. I can say this is the height h. From the same height, there is another body called 10 kg is dropped here, right? The question is, which body will reach the ground first? Which body will reach the ground first? That's my question here. Understand? Now, the second case. Second case is also the same. So it's a ground here. This is the ground, and you can see clearly, and there is a mass, same mass here. I can say it's a 1 kg, right, which is dropped, and the same height, at the same height 10 kg mass is also dropped. Height h is same in both the cases. Question is, which body will strike the ground with more velocity? Understand? So I am writing here, which body's striking velocity is more? Which body's striking velocity is more? I hope you understand the question. Let's concentrate on the first one, right? So I am telling you again, commonly do mistakes by the students in these cases. Let's start. 2 important cases for the NEET exam. So there is a body of mass 1 kg dropped from some height. So there is another mass called 10 kg which is also dropped from the same height. The question is, which body will reach the ground first? So 99% of the students will tell that. So 10 kg body will reach the ground first. So these are the cases we are discussing in the absence of air resistance. There is no opposition from the air. So these are the cases we are just assuming, remember. So whenever this kind of questions will be asked, so you need to assume that, so under the absence of air resistance, and these are the questions they are asking, right? Are you ready now? Which body will reach the ground first? Let's talk about the times. That's it. If you understand the concept of the time taken by this body to reach the ground and time taken by this body to reach the ground, and you will understand which body will reach the ground first. If it is taking more time, it is coming first. It is taking more time, so it is coming first. That's it. So both the bodies are dropped. I said u is equal to 0 in both the cases, right? In both the cases, acceleration due to gravity is g, because we are talking about on the surface of the earth only. Acceleration due to gravity is g, right? So time, let me take h is equal to ut plus half gt square form here. From here, as u is 0, and I can write h is equal to half gt square. From here, I can write t square is equal to 2h by g, and from this I can write t is equal to square root 2h by g. Carefully see. This is the expression for this body as well as this body, right? To time taken by this body to reach the ground. This is the only expression we have. Okay, in this case. This is the time taken by the body is depending on what parameters we need to check now. Time taken by this body is depending on root of h, height from which you drop, and g, acceleration due to gravity. Okay, clear? Only these two things. So, is this depending on any mass of the body? No, right? Mass of the body? No, there is no mass of the body expression here. You understand? So, time taken by the body is depending on height from where you are dropping the body. In both the cases, height of dropping both the bodies is same. Yes or no? Tell me. Yes, h is same in both the cases, and g. So, this time taken by the body to reach the ground is inversely proportional to g. Inversely proportional to g. So g is also same in both the cases. Okay. Acceleration due to gravity is same. H is same. 2 is anyhow constant. So what will you understand in this case? So both the bodies will reach at the same time. I hope it is very clear to you. I can say time taken by 1 kg mass is equal to time taken by 10 kg mass is same. Both will reach the ground in the same time. So I can say which body will reach the ground first? Both will reach the ground at the same time. Okay, same method you can apply here also. So there are two masses which are dropping from the same height called h. So one mass is 1 kg and the second mass is 10 kg. So the question is, which body's striking velocity is more? So which side striking velocity is more? So here also 99% of the students will tell that the 10 kg body will be having more striking velocity at the ground. Okay, so let's talk about the striking velocity, and we know v square minus u square is equal to 2gh. So here u is equal to 0 and here also u is equal to 0. So from this expression, so striking velocity can be written as root 2gh. Striking velocity means, so the body will be reaching to the ground with a velocity just before striking. That's called the striking velocity here. So v is equal to root 2gh. So the striking velocity is depending on what? Striking velocity is depending on acceleration due to gravity. I have told you already. So both the bodies are dropping from the same height. So their acceleration due to gravities are same. And the striking velocity is also depending on height from which the bodies are dropped. So in both the cases, height from which the bodies are dropped is same. Are you getting the point here? So g is same, h is same, 2 is anyhow constant. So then what is your answer? So both the bodies will strike the ground with the same velocity. Yes or no? Tell me. So what I can write here, v of 1 kg which is equal to v of 10 kg. So I can write here, so both will strike the ground, with the same striking velocities. it clear? So these are the two important cases for your NEET exam, and this is also the model where the questions was asked in previous NEET exam, directly or indirectly. So this is what the dependency of acceleration due to gravity on the other parameters except the mass of the planet, or mass of the body. And here also you can see here. So mass of the body, time taken by the body is independent of mass of an object. Time taken by the body is independent of the mass of the object. Okay, clear? So these are the important cases, and we'll continue now. So look at here, this is what we had already discussed. Okay, some of the points which are written here. Acceleration due to gravity is equal to G capital M by R square, which is on the surface, right? So acceleration due to gravity is depending on mass of the planet and depending on radius of the planet, or the distance between the two masses. Okay. So there are some more factors which are affecting your acceleration due to gravity value. What are those some more values? Some more factors. Let's start. Number one, shape of the earth, right? And number two, altitude means height taken from the surface of the earth. Number three, depth taken from the surface. From the surface of the earth, I have told you clearly, when you're taking the body to some height, the small g value will decrease. When you are taking to some depth towards the center from the surface of the earth, your acceleration due to gravity will decrease. And the shape of the earth, right? You know, the shape of the earth. Let's start from the shape of the earth. And you know, the shape of the earth looks like this. Understand? So this is what the equatorial region. So this is the equator, and this is what the poles here. So you can clearly say that the radius of the earth is more at what? More at the pole or more at the equator? So definitely radius of the earth is more at the equator. Understand? Clear? So what I can write here, so radius of the earth is more at the equator than radius of the earth at the poles. Carefully see this equation here. Okay, now from this equation we know general equation, acceleration due to gravity is equal to capital G into, I'm talking about earth, right? Capital G into mass of the earth divided by radius of the earth whole square. So look at the interesting point here. Capital G is, say for example, if you keep the body here, if you keep the body here, if you keep the body here, carefully see. If you keep the body here or here or here, what happens? Capital G value will be same and the mass of the earth also will be same. Okay. Now only thing differs here is radius of the earth. So at this point, if you keep the body, earth radius of the equator is more. At this point you keep the body, radius of the earth is having the pole, it's less. So what I can write, so acceleration due to gravity on the earth's surface is inversely proportional to, carefully see, inversely proportional to a radius of the earth whole square. Okay, so what you will understand. So when the radius of the earth at that particular point is more and acceleration due to gravity at that point will be less. And if the radius of the earth at particular point is less, acceleration due to gravity will be more. So that's it. So where the radius of the earth is more? At the equator. So then acceleration due to gravity at that point must be less or more. So if the radius is more, acceleration due to gravity must be less. So that's what I am writing here. So in this case, look at here, radius of the earth is more at the equator, and at the equator acceleration due to gravity must be less. So that's what I am writing here. So carefully go through this. So radius of the earth at the equator is greater than radius of the earth at the poles. Exactly inverse relationship the acceleration due to have. Acceleration due to gravity at the equator is less than acceleration due to gravity at the poles. Okay. Okay. So the conclusion is as the particle is taking from earth to equator to the poles. Equator to the poles, acceleration due to gravity increases or decreases? So from the equator to the poles, acceleration due to gravity increases because the radius is decreasing. Are you understanding? So radius is decreases, acceleration due to gravity is increases. When we are moving from poles to equator, what happened to acceleration due to gravity? As the radius is increasing, acceleration due to gravity decreases. So that's it. Understand? So what that statement I'm writing here. So when we are moving from equator to poles, so G value will, tell me, moving from equator to pole, radius is decreasing, then acceleration due to gravity will increase. You got the point? And you may get a doubt here. Sir, acceleration due to gravity on the surface is 9.8 meter per second square everywhere. Then how it is decreasing or increasing? We are talking about only on the surface, anywhere. That may be at the poles or the equatorial region. But how it is more or less? You know, on the surface of the earth, imagine if the acceleration due to gravity at the poles is some 9.85 meter per second square, right? So acceleration due to gravity on the earth's surface, maybe it's 9.82 meter per second square. So is there any much variation here? As we are moving from poles to acceleration due to gravity on equatorial region, I can say it is equatorial region. What happened? So acceleration due to gravity is decreased by how much? By 0.03 meter per second square. That doesn't make any much difference in your calculations. Understand? So like that small difference, small variation will be there. So no need to worry. What you should understand from this application is simple. As the radius of the earth is varying at one different point, so acceleration due to gravity also varies. How it varies? In this way. When we are moving from equator to the poles, as radius is decreases, acceleration due to gravity will increase. That's it. Okay. So let's start. The second factor affecting your small g value. What's the second factor affecting your small g value? It's altitude. What is the altitude here? It is height taken from the surface. So that's very important application. So the number 2. Look at this. Very important application here. So the diagram I'm just drawing here, the simple diagram I'm drawing here. So this is what, imagine the radius of the earth here, radius of the earth. Now the body is not taken here. For example, first case, body is kept on the surface, right? See here, small body, capital mass is mass of the planet. So that planet may be mass of the earth. And small body is kept on the surface. So here we are talking about the second factor called altitude. Altitude means height taken. Okay. So now here the first case, on the surface, when the small body is kept on the surface, we had already discussed acceleration due to gravity on the surface of the earth is equal to capital G, capital M suffix E by radius of the earth whole square. And look at the interesting part. This can be written as G into M suffix E is equal to small g E into R E square. Can I write like this? Imagine it is equation 1. So why I am writing like this, you will understand it later. Just wait for a moment. Okay. So this is what acceleration due to gravity on the surface of the earth you already know. Now the body is taken to some heights. It's not on the surface of the earth. The second case, what happened? H is the height taken by a body from the surface. H is the height taken by the body from the surface. From the surface. Second case, the same mass is taken to some height h. Carefully see. Some height h. So this is the second case. Mass small m is kept. Now, acceleration due to gravity at that particular height. Acceleration due to gravity at that particular height is equal to capital G into, so mass, see here, so mass of the earth, planet is not changing, divided by RE square. This is important point. Because our basic formula is this one. Acceleration due to gravity is equal to Gm by R square. What is G? Constant. What is M? Mass of the planet. What is R? So many times I've told you R is not just the radius. R is not just the radius of the planet. When the body is kept on the surface of the earth, the R will be the radius. For example, the body is taken to some height h. What is your R? You know, R is the distance between the two masses from their centers. So the first mass is the huge mass, its center is here. The second mass is small mass, its center is here. So what is the distance between the two masses here? Can I say the distance between the two masses is RE plus H? Will you agree with this? Sure. So GME by RE plus H whole square. Is it clear? Sure? Now, carefully go through this. So this is what I can write, acceleration due to gravity at some height. This is a formula. And here I can also write G into M suffix E from equation 1. It's G E into radius of the earth whole square divided by radius of the earth plus H whole square. Okay. So what I can write? Acceleration due to gravity at some height is equal to G suffix E into R suffix E divided by R suffix E plus H whole square. Carefully see this. Understand? Clear? So, acceleration due to gravity at some height is equal to G suffix E into R suffix E by R suffix E plus H whole square. It's a simple derivation we have done. And the most general expression is here is, so G suffix H is equal to G into R by R plus H whole square. So this is what a general expression. General expression. Okay. Clear? Sure? Let's see the important point here. How the questions will be asked in this case. Right? Let's see the example question. Simple example question. At what height, simple example question I am writing here. At what height acceleration due to gravity will be, carefully see, acceleration due to gravity will be 1/4 of its value on the surface, carefully see, surface of earth. You can check your previous NEET exam question papers. I'm sure that in one of the years this question was there. So simple. At what height acceleration due to gravity will be 1/4 of the acceleration due to gravity on the surface of the earth? What's the question? At what height? So we need to find the height. What is the given data? At this height, what is the given data? Acceleration due to gravity at this height is 1/4 times of acceleration due to gravity on the Earth's surface. You got the point? Clear? Sure? Now, look at this interesting part. So what is the formula? Immediately you should recollect the formula. Acceleration due to gravity at some height is equal to G into R by R plus H whole square. So I am writing the formula here. So G suffix S, which is equal to G into R by R plus H whole square. G suffix H. What is G suffix H is given? 1 by 4 times of g suffix e, which is equal to, so g suffix e, this is the acceleration due to gravity on the earth actually, okay. So this is g, this is re, and this is re, into re divided by re plus h whole square, and you can see ge and ge gets cancelled, okay, clear. So here 1 by 4 is equal to re by r plus h whole square is there. So if you apply square root on both sides, and what will be this? So this is root 1 by 4, which is equal to r by r plus h, that's it. Understand? Clear? So here root 1 by 4 is equal to what? Root 1 by 4 is equal to 1 by 2. Can I write like that? Root 1 by 4 is 1 by 2. So now cross multiply here. R plus h into 1. What is that? It is r plus h, which is equal to 2 into r. It's 2r. So what I can write? H is equal to 2r minus r. It is r. What is the radius of the earth? They will give the radius of the earth, you know. So the radius of the earth is 6,400 kilometers. See how effectively we have found the answer. When height of the body is taken to the height which is equal to radius of the earth, means 6,400 kilometer, acceleration due to gravity will be decreases. Okay, so look at the interesting thing. Here the surface. From here, when we are moving, acceleration due to gravity will decrease. At a height which is equal to radius of the earth, the acceleration due to gravity is equal to 1 by 4 times of acceleration due to gravity on earth's surface. Understand? So g value will be decreases at this height which is equal to capital R. Then g value will be 1 by 4 times of ge. Same question, same model. The questions can be asked in this way. Listen to me carefully. At what height acceleration due to gravity will be 1 by 2 of its value on the surface of the earth? Half of the value on the surface of the earth. Okay. So at what height acceleration due to gravity will be 1 by 3rd of its value on the surface of the earth? The concept remains same. Okay. I hope it's very clear to you, and this is how we can discuss the second factor affecting the acceleration due to gravity. Now let's discuss the third factor affecting the acceleration due to gravity in your next class.